Good day, everyone. I will be your teacher for today, Ma'am Nicole, and we will be tackling about rocks and minerals. So first and foremost, house rules, right? So first, mute your microphones unless necessary. Second, you can turn your cameras on if you're comfortable doing so. Third, utilize the raise hand feature in the text channel if you want to say something. And lastly, and most importantly, participate as much as you can. Let's have this quick check-in so that we could gauge what we know about this. So first, and the question that we have, what are the things you think about when you hear the word rocks? So through your annotation feature in your Zoom or your text box feature, you can add also stickers. Please answer the question above. All right. So with that, our learning objective for today is for the learners to classify rocks into igneous, sedimentary, and metamorphic. So without further ado, let's talk about rocks. So when we say or rocks, right, or stone, a rock or stone is a naturally occurring solid aggregate of one or more minerals. And that the Earth's outer solid layer, the lithosphere, is made up of rock. Also take note that many rocks contain silica, which forms crystals with other compounds in the rock, and that the types and abundance of the rock is dependent on where it is formed. And that it is important to note that almost 75% of the Earth's crust is actually made up of rocks. And that with that, it is now a question, how are rocks formed in the first place, and how do we classify these rocks at the end of the day? So, with this, the geological classification of rocks could be or is affected by certain characteristics. So, first, we have mineral and chemical composition, we also have particle size. We also have permeability and the texture of the constituent particles, among others. And that all of these things work together in order for us to have the general classes of rocks. So the question is, what are the three general classes of rocks, right? So first, we have igneous, we have sedimentary, and we also have metamorphic rocks. So in our lesson, we will tackle all of these kinds or all of these classifications as we go through. So first up, let's have igneous, right? So if igneous rocks form from the cooling of melted rock. So it can be either lava or magma into solid form. When we say lava, this is the molten material that can be found over or on the Earth's surface. When we say magma, this is the molten material that can be found under the Earth's surface. And that igneous rocks actually can be classified into two based on where the cooling occurred. So if the cooling occurred on the Earth's surface, or if the molten material that was cooled is lava, then therefore the classification is extrusive or volcanic from the root word ex, or something outside, not inside the earth's surface or underground, right? So examples would be first pumice, we also have rhyolite, we also have obsidian. Then another classification would be if the cooling occurred underground, or the molten material that was cooled is magma. So therefore the classification is intrusive or inside, or plutonic. We have granite, dolerite, and also periodolite. Periodotite, right? So, the question is, what did you notice about the appearance between intrusive and extrusive igneous rocks, right? What can you notice? So, we can notice that with extrusive igneous rocks, these are cooled quickly. So as a result, they are fine-grained or have a lack of crystal growth. Or also, we can notice that like these extrusive igneous rocks have bubbly appearance, like pumice. or glassy appearance like obsidian. Unlike intrusive igneous rocks, which are formed from magma that cools slowly, it results to coarse-grained rocks or rocks that has more crystallization or larger crystallization in it. So look at our examples and you can see that granite, dolerite, and also peridotite actually have larger crystallization than the extrusive igneous rocks. Then, moving on, right, we also have the sedimentary classification. So from igneous rocks, if it's from cooling of lava or magma, sedimentary rocks are from the root word sediments, or from compacting or cementing of sediments. However, like igneous rocks, sedimentary rocks are also classified into certain classifications. So we will be talking about the detrital and chemical. So it is about the nature of formation. So if the rock is formed by the compaction or of separate particles or sediments, then therefore it is classified as detrital. So for example, we have conglomerate. So as you can see, this rock is made up of different types of rocks or made up of rocks as well. It is of the compaction of other particles to form into a rock. With shale, this is made by the compaction of separate particles, as you can see with its lineation. Alright? But with chemical sedimentary rocks, its nature of formation is from minerals that have been dissolved in water and precipitated out. So for example, we have rock salt. So the process with getting rock salt is by evaporating and precipitating out NaCl. And with our sodium chloride precipitates, it forms into a rock salt. Then we also have limestone, which is formed by calcium carbonate or carbonate compounds, and also with its combination with certain marine organic materials or other organic materials, and that usually sedimentary rocks can be found near bodies of water wherein sedimentation could happen and compaction and precipitation could happen. So with that, are there any questions so far? So if none, let's move on to metamorphic rocks. So when we talk about metamorphic rocks, these rocks form when existing rocks are subjected to intense heat and pressure. So for example, we have granite, which is again an igneous rock, right? If it is subject to intense heat and pressure, we could have gneiss, and that therefore this process is actually called metamorphism, wherein this occurs when a rock is subjected to conditions unlike those in which it's formed. Another example would be when we have shale, which is a sedimentary rock, and if it's subjected to intense heat and pressure, it can then become slate. But even if slate is already a metamorphic rock, it can still undergo metamorphism, wherein it can then become phyllite. And also phyllite is a metamorphic rock, can still undergo metamorphism to become schist, and for schist to become gneiss. So the idea here is that igneous, sedimentary, and existing metamorphic rocks can actually undergo metamorphism to form a metamorphic rock. So with that idea in hand, for us to understand rocks furthermore, we can compare them through this table. So first, in their formation, we know that igneous rocks are formed when lava or magma cools and hardens. With sedimentary rocks, they are formed when small pieces of rocks, minerals, or sediments are compacted or precipitated out. But with metamorphic rocks, these are rocks that have been changed from heat and pressure. In terms of their appearance and surface, igneous rocks can have crystals, air bubbles, or a glassy surface, while sedimentary rocks, their composition can often have fossils or organic materials, or even other rocks in the rock, or basically other materials embedded on the rock. With metamorphic rocks, you can often see minerals in its composition. While in terms of where it is formed, with igneous rocks, basically most of the Earth's crust is made up of this rock. While in sedimentary rock, these are often formed near bodies of water. And in contrast with metamorphic rocks, these form usually in deep underground or where the magma cools down, right? But with all of these things considered, we can then understand that rock formation isn't an isolated process, that the rocks of Earth's crust are constantly being recycled and changed, and that therefore, through certain phenomena, it forms then new forms of rocks through geologic processes, and that this transformative cycle or transformative process is called the rock cycle. So to further understand, for example, if we have sediments, if it undergoes compaction and cementation, it becomes sedimentary rocks. If we have all of these rocks, sedimentary, igneous, and metamorphic rocks, if all of these undergo heat and pressure, it can then become another metamorphic rock. But if all of these becomes melted by magma and become then cooled and hardened through time, it becomes an igneous rock. But if these rocks are eroded or weathered, it becomes sediments through time. And also, at the end of the day, or after certain quite some time, through compaction and cementation, it becomes sedimentary rocks again. So as you can see, this is the transformative cycle that involves the rocks in this process. So with that, any questions so far? So if none, let's have this activity, rock and rolls. So in this activity, you will determine the geological classification of the rock based on how it was formed. So first scenario, we have rock B. So it's formed through the aggregates of calcium carbonate and silica through evaporation and precipitation. So what is its geological classification? Then for scenario 2, we have rock N, which is formed through the cooling down of the lava from a recent volcanic eruption. However, through time, rock N was subjected into its burial deep in the earth and in immense heat, resulting to rock J. So what is the classification of rock N and rock J? So with that, after answering that, we can now go back to our learning objective, and we can notice that we're able to achieve this, wherein the learners were able to classify rocks into igneous, sedimentary, and metamorphic. So I hope you were able to learn a lot about this lesson. You're able to reflect the importance of knowing about this and understanding how a rock is formed and how a rock is cycled through geological processes. And with that, thank you again for listening, and I hope you learned a lot of things for today.